let's go. Let's open the multiplexer source file. It is a multiplexer of 4 variables, and the goal is to deliver, to change it, to edit it into 16 input multiplexer. So first I will change the x to be a logic vector instead of a list of logic signals, yeah, simply, and the width of the vector is 15 down to 0, and here you've got to put the indexes in parentheses, and of course you must change the number of select lines, which is 4 in this case, and then you must put 4 bits here and 4 bits here and 4 bits here and so on. Yes, when others, and many lines here, here, and x1 must be put here, x2 here, and x15 when others. And let's write down also the last but one line, x14 when something 1110. It is 14. Okay, right? All right. So the next task for you right now is to design a full adder. Full adder. Do you remember full adder? No. Okay. So review full adder. That's it. FA, please. It is here. It is the truth table. Do you remember the equations? The equations were these. Okay. So try to change this. Okay. Edit this to have a full adder. Let's change the name as FA full adder. Here the full adder has 3 inputs, ABC, simple device, and 2 outputs. One is S, which is the sum. Let's call it sum, and the Cout is the carryout. Cout. These are outs rather, not ins, and you've got to put here. Okay. So let's remove these lines, and with select we are returning to the first option when you deliver the full name, the full equation. Simply equation for sum is the following, and equation of Cout is the following. You remember? Sum was what? XOR. Yeah, A XOR B XOR C. And what about Cout? A and B, or A and C, or B and C. What's correct? And you must put it in parentheses, because otherwise it will be executed from left to right. So ands and ors are of the same priority. Okay. So you must put even ands must be put in parentheses. Ands or ends. Put many, almost all of them, if you are not sure what the result will be. But do you remember another version of Cout? When I introduced propagation and generation functions. Okay? You remember propagation? What was the propagation and generation function? And if I put these A XOR B is how to express it? I can change this by factorize C from the last two. So A and B are as well the same, but now OR, and then I will do the following. A or B and C. Is it the same? Is it the same? Yes. A plus B times C is A times C plus B times C. Yes, it is the same, yeah? Or not? If you use dots and pluses, will be simpler. Looking at and or nay is more difficult for you. Okay, so it is the same. So I will remove it. And we, or I hope you, your task was to make sure that it is also true when it was and, sorry, mistake, if I change OR by XOR. Is it the same function? It is the same function. Okay, XOR is not OR, but as a whole, it is the same. Okay, as a whole. Okay, this version I wanted you to remember with propagation and generation. Okay, parts. Which one is a propagation? Propagation is this. A XOR B is a propagation element or subfunction, and A and B are generation function. Okay, you've got the same propagation here and here, so you can change it and introduce the intermediate signals. Here, just below the architecture, you can introduce the internal signals. They are available inside the ICs, not on the ports, okay? Because they are not here. Here you have A XOR B, let's name it G, which is, P, it is a propagation, and A and B will be G. These are signals. Signal should be put in front. That is signal PG. The set STD logic is, of course, because they are real signals inside the full adder. Okay, inside the full adder. So now I can change and use these as P. It is P propagation. Okay, I am calculating this at the beginning of the source file and the architecture. It is also A XOR B. I can use it. I can use P and put it here. And this function A and B is called generation. So I can calculate this and deliver here as a Q. G. These are intermediate values, and in the programming language you can calculate some part of the equation and then substitute this into the bigger one, yes, to obtain the overall result. So here I must put G. Is it the same? Sorry, propagation here and generation here. This is the full adder. Let's have a look. Let's make sure that the overall equation will be the one you know, XOR and something, yeah? AB type plus AC plus BC after compilation. So let's compile it first. Let's compile it first. So there's a compile option. And prefit equations. Look at these equations. What is it? A, B, C plus not A, not B, C plus etc. Let's have a look at my slide. It's this equation. Yes? Four minterms, 4 products added together. These are these. Sum. That's correct. What about Cout? Cout, as you know, is AB plus AC plus BC. Okay, but I have put here different. Yes, different version with XOR and OR. It is a maximalization rather than minimization. Okay, because I have put the minimized versions, and I got the canonical part, almost canonical in the first part, because inside these CPLDs there are AND or NOT gates only. There is an array, so I cannot use XORs inside the real device. Here I can put XOR if I know that the sum is the A XOR B XOR C, etc. But in the real device, these XORs will be implemented A not B plus not AB. Okay, so sum of products, not XORs. All right, so let's have a look. What will happen if I change the order? I use P and G first, and then calculate P and G values. In the programming language, it is not correct approach. You must initialize P and G to be used in the consecutive lines of the program. Here, the order of these lines is unimportant. You can randomly sort them. Okay, I can put P in between. It seems that different value of P will be used here and here. No, the same. Okay, it is the difference between the variable and the signal. I can change the order. Okay, it is not important. The order is not important here. So if I change, I have changed it. Okay, and then I will compile it, and we'll get the same equation, exactly the same. Okay, so be aware of it. It is data flow. They are concurrent. They are run in parallel, as in hardware is. Yes, it is the fact. Yes, and in hardware, everything works in parallel. Okay, even if you put lines one after another, they will be executed in parallel. Okay. So let's have a look. It is the difference, the first difference between variables and signals. And you will see the same equation here and the same equation here, independently of the order of the lines in your program. This is a very interesting, and you must memorize it. So let's stop